Hello everyone, and welcome back to Let's Make a Game. This is Snackrificial Chamber, episode 25, and today I added teleporters. As you may have guessed, these new track types will instantly transport cargo from the incoming teleporter to the outgoing teleporter. Let's get started. Once more, the first step in adding these new track types was to define them. I created a new type for both teleporter in and teleporter out. The first only sends cargo, and the second only receives cargo. I then created a new output type to be used by the teleporters. The teleporter in track has no output directions. If it fails to send cargo, the cargo can no longer proceed along the track. Likewise, the teleporter out track has no inputs. Cargo can only enter this track's space by teleportation. This is the first time one of the tracks did not contain any outputs, so I had to change the update input method of the GameTile class to show an edge piece if an input object was not defined. This ensures an edge lock is displayed when necessary. I then made a simple change to the getNextOutput direction method. If the track is a teleporter, it simply returns the current value of next output direction, which should always be -1 in this case. I needed two new prefabs, one for the sender and one for the receiver, so I created a simple light post structure to make these tracks unique, the color of which will change with the selected channel of the teleporter. The sender is surrounded by 4 input track pieces. The receiver also has the light post, but instead has a single output and no inputs. In order to manage the teleporters, I had to first alter the level build master class. I added the getTeleporterOut tiles method, which iterates over all tracks within the level and returns a dictionary of all teleporter out tiles as well as their positions. Next, I created the teleport master class to control all teleportation during gameplay. The teleporter outputs dictionary uses the channel as the key and a list of the available teleports as the value. The next teleporter dictionary also uses the channel as the key, but the value is the index of the next teleporter to use for that channel. Each time the deploy state is started, this class initializes these dictionaries. That way, if teleporters were added or removed, or if channels were changed, the cargo is still teleported to the correct location. Each of the maps are cleared out, then for each return teleporter out track, the teleporter position is added to the list for the given channel and the next index is set to 0. The list of teleporter positions for each channel is then sorted, so the behavior is consistent between multiple starts. When looking for the next teleport position, this master class pulls the position for the given channel and index. The index is then incremented and reset to 0 if it exceeds the length of the list. Although not all changes have been made yet, here's how the teleporters are expected to work. When the sender is activated, the signal lights flash and the cargo is instantly transported to the receiver. If the sender does not have a matching receiver, the track will activate again after a short delay, and the player must end the level and fix it to continue. Currently, I have 4 animation states in the cargo animator. The core state is the one that determines what happens next. This is the state that fires each time a track is activated. I also have full move, half move, and deploy. For teleportation to work as expected, I added a 5th state for teleporting and a teleport parameter that represents the channel. This state is automatically triggered when the teleport parameter is greater than -1 and returns to the core state when the teleport parameter equals -1. I then updated the check position behavior class so I could enter the teleport state. Before the cargo looks for the next output direction of the current track, it checks the output type. If the output type is teleport, the animator sets its teleport parameter to the channel property of the sender. Upon entering the teleport state, the teleport behavior is triggered. The teleport parameter is pulled from the animator. This class then tries to receive a destination position from the teleport master class using the channel value. If a valid position is returned, the cargo is instantly transported to that position, and the teleport parameter is reset so the core state can run again. If an invalid position is returned, which means there is no valid receiver, the parameter is reset after a delay, so it's not constantly activating. To teleport the cargo, I had to add another method to the GameCargo class. This method starts a coroutine that waits for the end of frame, so the cargo's position can be set. Finally, I created another GameTile child class called GameTile Teleporter. This class controls the color of the sprite for each prefab, as well as activating the teleport lights. When this tile is activated, the emitting property of the light material is set to on, then returned to off after a short delay. Now that all changes have been completed, here are the teleporters in gameplay once again. You can see that each receiver is only accepting cargo from the matching sender, and the sender alternates the target receiver when more than one exists per channel. That's all I have for today. I added sender and receiver teleporter track pieces, as well as a new animator state and the behavior class to support it. If you liked this episode, you can subscribe to my channel on the left, or watch more of my videos on the right. If you have suggestions, you can leave a comment or reach out to me on Twitter. Thanks for watching.